Hi everyone, welcome back to the organic molecule portions of our class. The next one that I want to mention or that I want to cover is the organic functional groups. So functional groups are basically atoms and how the carbon molecules are bonded to another thing. And the reason why we give each of these functional group different names is because they have different reactivity. And we want to, whenever you say an alcohol reacts in this particular fashion. So when you say it's carboxylic acid, they react in these particular fashions, and essentially the name tells us what kind of reaction is possible and how they behave in general, whether it's polar or non-polar and so on. So these is the next memorization that I want you to do. And the list is going to be quite a bit, but you'll see that there's actually quite similar in trend from one to the next to the next to the next. And once you get a hang of it, it's actually not that hard. So we'll begin with the simplest portion, one that we can have. We can have an alkane, and alkyne with a Y. It simply means an alkane, all of the carbon molecule is double bonded, single bonded, and when you have a double bond, then we're going to call it an alkane. And the last one is we have a triple bond, we're going to call it an alkyne. So these are some of the examples. This is an example of an alkane. It is something that looks like this. Okay, so all of these carbon molecules, all the carbon are single bond. An example of an alkene with an E is something like this. You can notice that here we have a double bond. And the last one, we can have an alkyne. And an alkyne, again, from our previous example, is triple bond. And triple bonded molecule is linear. So make sure that you put in the linearity is there as well. So this is a triple bond. Okay, so alkyne refers to carbon that is triple bonded to another carbon. Alkene is double bonded. And alkane is the simplest possible organic molecule. All of them just single bond. Now, the next functional group that I want you to memorize is called the aromatic group. There's actually a large group of molecule called aromatic, but I'm just going to focus on just simple one, which is the benzene molecule. And usually you're going to see organic or aromatic group that looks something like this. Now, the special thing about aromatic is that they're cyclic alkene. And again, alkene refers to the double bond that we have here. Now, the interesting thing about aromatic molecules is that the double bond, all of these molecules here, all of the carbon that we have on each of these hexagon edges are actually double bonded to one another. That is, the double bond could easily move from one side to the next. That is, there's a resonance structure, if you remember from your 14A series, that it makes a resonance that looks like that. So this, by the way, is particularly called benzene. Now, it basically flips around the double bond. The location of the double bond continues to flip around from one to the next to the next to the next. So sometimes you can also see it described or drawn in this particular fashion. So instead of a double bond individually written as a circle, just because the double bond location flips around between these two structures. So they're kind of all the same thing. The next one is the alcohol and ether. You'll find that there's going to be a series which is I tried to pair these functional groups next to one another because they're quite similar. But instead of the functional group binded to a hydrogen, it's going to be called something else. And then if it's binded to another carbon molecule, it's going to be called something else as well. So the first one is I'm just going to do an example of an alcohol. So an alcohol is a carbon molecule that is binded to the N with an OH group. So I have an O and H group there. So this OH group is an alcohol. Okay, that's an alcohol functional group. Now, if we simply replace this hydrogen with another carbon molecule, it's going to be called a different thing altogether. So the next one here is an ether may have a structure that looks like this. So we still have the same, something similar. It is bonded to an oxygen, but instead of bonded to another hydrogen, we can have another carbon molecules attached to it. Now this is now called an ether. This is called an ether. Okay. That is the carbon, the oxygen is bonded to two carbons in this case. Okay. Let's go on to the next one. There's quite a bit of a list here. In fact, this is just a truncated list. It's already quite numerous, so we're just going to take it easy with just this limited one because there's some of the most common one that you will see over and over again. So I do want you to be able to remember all of them. So the next one is an aldehyde. On the previous one, the oxygen molecule is single bonded to the carbon, but an aldehyde here is a double bonded oxygen, like that. So that's an aldehyde. Now, don't forget, if you're looking at this and it looks kind of weird, so why is there nothing there? Remember, we're eliminating all the hydrogen. So in fact, there's actually a hidden hydrogen molecule here that we're not showing. Because if the hydrogen is bonded to carbon, we don't have to show it. So that's a structure for an aldehyde. And a ketone is when instead of having a hydrogen, we're going to have a carbon molecules attached to it instead. So a ketone would look something like this, for example. There. So aldehyde and then ketone. And again, the difference between them is that an aldehyde is bonded, the carbon is bonded to hydrogen, but in a ketone, it's bonded to another carbon molecule. Okay, let's move on all the way to the top. We'll go into the carboxylic acid and esters. The carboxylic acid molecule is the one that you've learned in the previous class about acid bases, and carboxylic acid, and it looks more or less something like this. So we can have something like this. So there's just an alkane, and then in the end we have a double bonded oxygen, another oxygen, and hydrogen. Now this hydrogen is the acidic portion here of our carboxylic acid. Now the next one is we have an ester, so same thing. Instead of having a hydrogen at the end, we're going to have a carbon molecule at the end. So we can have an ester. So we can have an ester that looks something like this. So we still have carbon molecule, double bonded oxygen on the top, another oxygen, but instead of another hydrogen, we can have another carbon molecule attached to it. So it's fairly similar to esters. Esters are very similar to carboxylic acid, but just replace the hydrogen with another carbon molecule instead. Okay, the next one for our functional group is the amines. There's actually a lot of different kinds of amines, and amines itself is an umbrella term, but we're just going to do some of the simpler one. You don't have to worry too much of primary, secondary, and tertiary, but it's useful to know. So an amine is essentially just molecules that are bonded to, at the end, an NH nitrogen molecule. Okay, so this is amine, and you can see that this amine is only bonded to one carbon. So this particular amine is called a primary amine. And you could probably guess what happens in the next one. So if I were to do a secondary amine, it would look something like this. And H. And then let's draw another carbon molecule sticking upward. Okay, see, this particular amine have 2 carbons attached to it, so it's called a secondary amine. And the last one is we have a tertiary, which simply means that the nitrogen molecule have 3 carbon molecule bonded to it. So this is a tertiary. There's actually one last one that is very similar, but instead of being called an amine, it's actually called a quaternary ammonium. And this would have a nitrogen in the center, and you can have 4 carbon molecules attached to it, but because when you have 4 bonds in a nitrogen, it's a plus charge, so that's why it's called an ammonium molecule, because of the plus charge. But essentially, quaternary ammonium compounds simply have 4 carbon molecules attached to the nitrogen. Okay, the next one is the amide molecule, and it's kind of a combination between an ester as well as an amine. And an amide is essentially the one that's responsible for linking our protein from one another. So the amino acids are linked together with amide bonds. So an example of an amide would look something like this. I have double bonded oxygen, nitrogen, and a hydrogen, and then we can have another carbon molecules attached to it. Okay, so this whole thing here is called the amide. Okay, and you'll see this quite a bit in protein. And the last one here is haloalkanes, and halogen or halogenated molecule is fairly common as well. And in fact, majority of these substitute sugars are halogenated. So we simply replace the hydrogen with a halogen, which is bromine, iodine, and so on. And I just kind of want to give it a name for all of these structures. So let's do one at a time. I think the first is chlorine. So if it's bonded to a chlorine, it's grouped under haloalkane. This is going to be a chlorocarbon. And I want to highlight the chloro here. The next one, we can also have it binded to a bromine. So this is a bromo group. The next one is if it's binded to an iodine, is iodo. And the last one is if we are binded to a fluorine, then it's going to be called a fluoro. Oops, I don't know if I forgot to draw the bromine there. All right, so these are the groups for haloalkanes. Essentially, they're just binded to a bunch of halogens. If you look at your class planner, you'll find that there's a huge list of tables that I found of the different kinds of functional groups. So we have alkene, alkyne, and some biological example of where you can find them. This covers majority of the functional group that we saw. So for example, if you see fat molecules, you can see a bunch of double bond or an alkene molecules. If you have a sugar molecule, for example, you can see a bunch of aldehyde, you can see a bunch of alcohol, as well as ketones when they're bonded together. So these are some pretty good lists in terms of where to find these organic molecules as well. One last one before we end this particular video is I want you to know that these functional groups are not exclusive. That is, you can have a molecule with multiple functional groups attached to it, and in fact, majority of organic molecules have a lot of different things going on at the same time. So an example that I want you to see for the last practice of this video is to look at the structure of amoxicillin. This is just an antibiotic, and I want you to name and identify the functional group of this one. So this is number 1. I want you to identify this one, so that's 2. Identify this one, 3. Identify this one, 4. And the last one is that one, 5. So what is number 1, 2, 3, 4, and 5? So do pause the video, look at your notes from the one that we filled in before, so these ones, and try to figure out what the functional groups of the molecules in amoxicillin that we have here. There are things that we're not covering, like that one, but don't worry about it too much for now. Okay, so do pause, and then when you're ready, just play it again, and I'll write down the solution. Okay, so hopefully you've kind of paused the video and wrote down your solution. So number 1, which is this one here, is this particular functional group, is going to be a carboxylic acid. Number 2 is that we have a double bonded oxygen here, and then a nitrogen, and it's bonded to things like that. So this is going to be an amide. Number 3 is we have an NH2 at the end here, so this is going to be an amine. And if you want to know, this is particularly a primary one, but I'm not going to worry too much about that. The number 4 is a cyclic alkene molecule, so this is going to be called a aromatic. And the last one here is an OH group on number 5, and this is going to be called an alcohol. Alright, so that covers the second portion of this particular video, which is the functional group.